Hi, this is Mr. Hodgen, and this is the Algebra 1 review for the first quarter final exam. Let's get started. To begin, look at number 1 and identify what number is in front of the parentheses here. So we have to make sure that we see a negative 2 here. So we do negative 2 times x and we get negative 2x, and negative 2 times 3 to get negative 6. Alright, we can bring down everything else and then start solving. Okay, so 5x minus 2x is negative and a positive 3x. And then we have minus 6 equals 8. I'm going to add 6 to both sides. Okay, so we have 3 times what is 14. And then divide both sides by 3. And we get x, 1x, equals 14 thirds. And leave your answer as a reduced fraction, no decimal, no mixed number. Okay, number 2. Several ways of solving number 2. Fastest way is to identify that this is a proportion, which means you have two fractions that are equal to each other. So one truth with proportions is that if you cross multiply, they'll be equal to one another. So 6 times x plus 2, notice I added the parentheses around x plus 2, will be equal to this diagonal, 8x. That's only true when you have one fraction equal to another fraction. And now we can solve this. So we have 6 times x and 6 times 2. And we'll subtract 6x on both sides. Okay, so 12 is 8 minus 6 is 2 times what number? So 2 times what is 12? And divide both sides by 2, and we get 6. And of course, you can always plug it back in and check. Does 6 over 6, does that equal 6 plus 2 over 8? Well, 6 plus 2 is 8, so does 6 over 6 equal 8 over 8? And sure enough, they both equal 1. So you can check your answer. Alright, which of the equations does not have the same solution? So let's find the answer to this. Okay, and then we can solve the rest. So 2 minus 7 will be negative 5. So we're going to have negative 5x plus 1 equals negative 4. Subtract 1 on both sides. We have negative 5 times what is going to be equal to negative 5. So that should be 1. And we can show that by dividing both sides by negative 5. So we have x equals 1. Now, which of these does not have the same solution? Very careful here. So, if it does have an answer of 1, we're not going to circle it, because that's not what they're asking. So, on the first one, does 1 minus 1/4 equal 3/4? It does. Okay. Here, plug in 1, so we have 3 times negative 6, that equals 18. So 1's an answer for both of these so far. Plug in 1 right here. 2/3 plus 1, that does not equal 15. So C would be our first one. And then plug in 1 right here. So 1 minus 5 is negative 4. Negative 4 times 3 is negative 12. On this side, if I plug in 1 right here, I get 2 minus 14, which is also negative 12. So 1's an answer for D as well. So C is the only answer that is not equal to 1. Alright, good. Let's keep going. Top of the next page. Yeah. Alright, solve each equation, determine the type of solution. Okay, so remember for these two, these have no variables left over. No variables. This one, the last one, does have a variable x. 1x equals 0. So if you have no variables, it's either all reals or no solutions. And when you have all reals, that's when you get something that's true, a true statement left over with the numbers, and a no solution when you have a false statement left over. Okay. So starting off here, we get 6x minus 6 equals 6x minus 1. And you can see if you subtract 6x on both sides, you have no variables. Right? This is 0 and this is 0. You're left with negative 6 equals negative 1, and negative 6 is not equal to negative 1. That's false. So this is a no solution. And actually write out the words no solution. Alright, keep going. We got half of 10, which is 5. And we have half of 8, which is 4. And you can see that these are identical in every way on both sides. And if you were to start solving, subtracting 5x on both sides, what you're left over with is something that is true. We have 4 equals 4. That is a true statement. So this would be in all real numbers. So on both of these, the variables, there are no variables, they're canceled out, just like we said earlier. On the left side, there's something left over. These are not the same. It's a false statement, so it's no solution. Here, that's the same number, so it's all reals. Okay, let's keep going, solve both of these. So subtract 9 on both sides. So 1/3 of what number is 0? Okay. And if you multiply both sides by 3, 3's will cancel, and x equals 0. Okay, and one more to solve here. You can add 12x to both sides, and subtract 2 on both sides. So that's 0, that's 0, so the whole right-hand side is 0. That's 0, and they're asking, let's see, 12 minus 7 is 5. 5 times what? 5 times what is 0? That'd be 0. Show that divided by 5 on both sides. So both of these do have a variable left over, right? They both have an x. They don't cancel out. So they have answers. In this case, they're both equal to 0. So that's the difference between here, where both variables are gone, right, on both sides, they equal 0. So there's no variable whatsoever on either of these. But on these two, we do have a variable. Like here, you see, these don't both equal 0. This one equals 0, but this one does not. So we know we have an answer. All right, let's solve some inequalities. Okay, first step here, there's two ways of doing this. I suspect they want us to first multiply by -2 though. So if you do that, you have -2, right, and 8, and then we have -16. That'd be greater than 18. So that looks like answer B. That's pretty quick. Okay, solve and graph number 6. Okay, now from the very beginning, I can see that this coefficient is negative. So I'm going to end up dividing by negative, which means I'll have to flip the sign. So my final answer should have a greater than or equal to in it. That's something you can identify from the very beginning just by seeing that there's a negative on the coefficient in front of the variable. So keep that in mind. We'll do that later. Add 3 to both sides. And here's where you're going to divide by that negative, right? So divided by negative, so we're going to have n is greater than -2. And this is going to be a solid circle since this is greater than or equal to. So I'm just picking a random place, calling that -2, and greater than would be this direction. So you don't have to spend the time and put -1, 1, 0, 1, 2, 3, and do the whole number line. Just put the number and open close circle and the arrow in the right direction. Okay, so that's page 1. Let's go to page 2. So more inequalities. These are compound, so it's 2 inequalities in 1. Alright, so we treat this the same way as we would normally. We have our variable here, so we're going to start by adding and subtracting. The only difference is that we have to add it here, but we also have 2 places, not just left and right, but we have left and right and the middle. So we're going to add 2 to all 3 places, like that. So we have 12 less than or equal to 3 times the number less than 18. And now, same idea, divide everything by 3. So 12 divided by 3 is 4, 3 divided by 3 is 1, and 18 divided by 3 is 6. So we want all the numbers between 4 and 6. So we have closed circle for 4, because this is an equal to, open circle for 6. And again, I'm just picking arbitrary places to put these. And you don't really need to put 3, 4, 5, 6, and 7, just like that. And of course, since this is a in-between statement, the graph just connects everything in between those 2 numbers. This is kind of like the opposite. As far as the graph goes, instead of being connected, they're going in different directions. So if we solve both of these, 24 divided by 2 is 12, half of 24. Add 6 here, we get 19. 19, that's 16. There we go. Both open circles. Okay. We'll put those 2 here. 12 is smaller, it's going to be on the left. 19 is on the right. And these are going away from one another. I know that because of the statement or, but I also know because the inequalities are pointing in the opposite direction. 12 is going to the left, 19, this one's going to the right. Okay, same idea as we did on the front side. We have the all reals, no solutions, and we're still looking for something that's true for all reals and something that's false for no solution. Okay. So we begin here by subtracting 3x on both sides. Okay, is 9 greater than 5? Okay, yes, 9 is greater than 5. Bigger than 5. That's true, so this is all reals. All real numbers. Okay. Go ahead and solve this. Distribute, we get 16x minus 8. Is that greater than or equal to 16x minus 1? And if we solve this by subtracting 16x on both sides, we'll get negative 8, right? Negative 8, is that bigger than negative 1? And that is false. Negative 8 is smaller than negative 1, so that's no solution. Okay, just a few more. So we have 2x minus 10. Is that less than 2x plus 14? Go ahead and subtract this on both sides. And we have, is negative 10 less than 14? Yeah, negative 10 is less than 14. That's true. So once again, we have an all real number. And lastly, if we do this, is 4 less than or equal to 4? Yes, 4 is less than or equal to. Because of the equal to part, this is true. So again, we have all real numbers. So if this last one did not have the equal to, if it was just 4 less than 4, that would be false. Because 4 is not less than 4. So that equal to part makes a difference. Even though these are the same number, this is a false statement. 4 is less than 4. Alright, let's go back up to the second column on the second page. And start finding slope, or rate of change, they call it here as well. So rate of change, right, that's the same thing as slope. couple ways of doing this. Just because it gives us a table, you can use that table method where you can see from 10 to 8, that goes down by 2, and from 0 to 1, that goes up by 1, and slope is rise over run, that'd be y over x, so that's -2 over +1, which is just -2. So that's one way of doing the slope. Another way is using the formula. So we have this method, right, using this formula. Subtract the y's on top, the x's on the bottom. And you can use any 2 points. It doesn't matter which 2 points. I could use like 1 and 8 and 3 and 4. It does not matter. As long as you have the y's on top, 8 and 4, and the x's on the bottom, you're okay. So we have 4 over -2, which is -2. Right? Same thing we've got up here. So either method works. If you have a table, this first method is probably faster. If they give you just the points, maybe you prefer the formula. Alright, so find the slope here. So a couple ways of doing this is we can find out what these coordinates are. This is going to be 2, -3. And this is going to be, what we got here? 1, 2, 3, 4, -3. Right? And you could use the formula that way, but a faster way might be just to count the rise and the run. Now the rise here is 0. So from here, I don't have to go up or down. So the rise is 0, and the run is 2. And 0 divided by anything is 0. So, or you could use the formula, plug that in, and you'll find that on the top you'll get -3 plus 3, which is 0, and then 2 minus 4 on the bottom, which is -2. Same thing. Slope here, x equals -2, that would be a vertical line. So if I put, just on this graph, I put x equals -2. Remember, that's the line with the x-coordinate is always, I'm sorry, +2. That's the line where the x-coordinate is always 2. So this is 2 comma something, this is 2 comma something. So if you try to do the slope here, the rise would be 2, but the run would be 0. So if you try that, it'd be 2 over 0, and if you had a calculator, right, and you tried to do that, it'd say 2 divided by 0, and it'd say you can't divide by 0. So that's why we write undefined. It's impossible to divide by 0 in mathematics. That's an undefined slope. The equation is x equals 2. So undefined slope doesn't mean there's no equation. It just means that the run is equal to 0, and we can't divide by 0. Here we go. Let's look at these. Okay, consider line A, y equals x plus 3, and line B, y equals 1/2 x. Okay, something might help here. Let's put in some missing numbers. So x plus 3 is the same as 1x plus 3. So my slope here is 1, and my slope here is 1/2. We don't have a y-intercept here, so that's the same as a y-intercept of 0. This has a y-intercept of 3. So that might help on some of these. Okay, steeper, which just means bigger slope. Okay, we're talking about slope here. Steeper would be a bigger slope. So does line B have a bigger slope than line A? And that would be no, because line B is 1/2, and that's smaller than line A, which is just 1. So that's false. Line B goes up and to the right. Yeah, so we have the rise is +1, the run is +2, so up 1, right 2. That's true. Line A is translated or moved up from line B. So if we just moved up this line A, would it actually be the same thing as line B? And no, that would not be true. Alright, let's keep going. Lines have the same rate of change slope. No, one of them is 1/2, one of them is 1. That's not true. They have the same y-intercept. No, one of them has a y-intercept of 3, the other has a y-intercept of 0. So that's false. There we go. Alright, let's go on to page 3. Let's see what happened here. Okay. Let's get it on. There we go. So here we have a graph, 12. Answer some questions about the domain and range. So is this function a relation, or is this relation a function? So we use something called the vertical line test. Basically, if you draw a vertical line anywhere, if it only touches one point at a time, then that means vertical line. That means yes, it is a function. So each of these vertical lines, and no matter where I drew a vertical line, it only touches at one point. So yes, it's a function. Okay, and you could say explain. Okay, because of vertical line test. The vertical line test, and you can write that out. Vertical line test. Continue, is this graph continuous or discrete? Basically, since this graph, you could graph this yourself without lifting your pencil. Okay, so from here to here I could draw that, and I don't have to lift anything. It's from one end to another. Okay, that's called continuous. There's other definitions of continuous, but that's the fastest way to identify, looking at a graph, if it's continuous or not. Okay, so we can write continuous. Let's look at the domain. So looks like domain is going to be the x, right? And that starts at 0. Right? That's where the first point goes. And then all these points all the way up to 20. So that's basically everything from 0 to 20 is the domain. And in a similar way, for the range, it starts at 0 and it goes up to here, 10. Right? This is the lowest point, this is the highest point. So the range is from 0 to 10. And so we write that domain is going to be from 0 to 20. And domain's x, so I'm going to use an x. And the range is from 0 to 10. And that's on the y-axis, so I'm going to use the y variable. And this is the same way we'd use Desmos to put in domain and range that we practiced in class. Okay, let's look at this, another graph. You can see this one looks a little different, right? So let's look at basically in every way why it's different. So first thing, vertical line test is this relation to function. Once again, if we did it here, you can see a vertical line would hit 2 points. So therefore, no. Not a function, and same reason because of the vertical line test. Is it discrete or continuous? So this is the opposite of the one we had earlier. We cannot graph this. I cannot make these points, the whole graph, all of these, without lifting my pencil from one to another. So that's one way to figure out from a graph if it's discrete or continuous. So this one is discrete. And domain and range. So since it's discrete, we're just actually going to list these numbers because there's no numbers in between like before. Before is everything from 0 to 20 for the domain, including all the fractions and decimals in between, but these are just single points. So we have something at 1, something at 2, but nothing in between it. There's no line, no points in between. So our domain is simply 1, 2, 3, and 4. And you just list them as such. 1, 2, 3, and 4. 3, 4, and we use these braces just like we did on Desmos. Always use those braces. Range, very similar. We have 10, 15, 20, and 25. So just list them. 10, 15, 20, and 25. So with continuous, you get a different, all the fractions and decimals between 0 and 20. It's everything between here because of, these are all points on the line as well, right? All these fractions and decimals. So we say everything, every fraction decimal between 0 and 20, or between 0 and 10, but these are just points. Nothing connected between them, so it's just those numbers where they land. Okay, good. Let's go over to the right column and do some intercepts. Okay. So define the x-intercept. That means at the very end we want x equals, right? So that's a good clue or way to remember that we want to plug in 0 for y. Because if you're looking at a graph, the x-intercept, wherever it may be, on the x-axis here, the y-coordinate is 0 when you're on the x-axis. So we just say, well, this whole thing is 0, so we get x equals -8 when we plug in 0. And same idea for the y-intercept. If we want to find the y-intercept, when you're on the y-axis, the x-coordinate is always 0. So we plug in 0 for x. So we get 4y equals -8. 4 times 1 is -8. So divide by 4. -2. Okay? And we could write this as, take our y and our x and make that -8, 0. And we could take this, our x is 0, and our y is -2. So that's the actual coordinate of the y-intercept and x-intercept. Let's go ahead and graph. So here we have to know that the slope is 4 over 1, not just 4, but the run is 4 over 1. Okay, so we're going to start at -1 and go up 4, 1, 2, 3, 4, and over 1. I'm going to do that a couple times. 1, 2, 3, 4. We could also go the other direction if we wanted to. Right, and then use a straight edge. There we go. So if there is no run, just make it over 1. Here we go, we got a -1/2. So right away we know since it's a negative slope, this should be going downward. Right? Keep that in mind, so make sure your final graph is going in the right direction. So we have to go down 1, right, down 1, and right 2. So I just rewrote this just to put the negative on the top. So I'm going to start at 5. 1, 2, 3, 4, 5. I'm going to go down 1 and right 2. And again, use a straight edge here. Yep. And let's go ahead and solve this one for y. So probably got to get this by itself. So I'm going to subtract 2y on both sides. 2x on both sides. Then I'm going to divide by -3. That's 0, so I'm left with this, -3y. I'm going to put the x part first, so I'm going to sneak that right in there. Then divide by -3. Y equals, and be careful here, we have a negative over a negative, so that's just going to be positive 2/3 x. And then we have 9 divided by -3 is -3. 1, 2, 3, up 2, right 3. There we go. Let's go to last page. So your last problem will be like one of these. I'll have one of these. So Candy Connection, jelly beans are sold by the pound. Jelly beans cost $5 per pound. X represent the pounds and Y represent the dollars. So create a table. All right. Now, just like on the homeworks, put our X and Y, but also put the label on there. And they give us the labels here. X is pounds, so pounds, and Y is cost. And we could go right ahead and put that on our graph as well. We can have our X, which is going to be pounds, and our Y, which is going to be cost. Okay. So let's see here. So if we bought 0 pounds, obviously that would not, if we didn't buy anything, right, that wouldn't cost us anything. But if we bought 1 pound, and we know 1 pound is $5, so that costs 5. If we bought 2 pounds, that'd be 10. And you can probably see the pattern from here. Alright, so you can see that my X's are counting by 1, my Y's are counting by 5. Right, so on your graph here, you probably want to do the same thing. You can count by 1s here, right? 6, 7, 8, 9, 10, and so on. But on the y-axis, probably count by 5s. And so on, just keep on going. And then we can plot our points. We had 1 pound was $5, 2 pounds was $10, 3 pounds 15. And then just like we did on the table, now you can see a pattern with our plots and just keep on going. There we go. And technically this will keep on going forever. We can take this up to $50 and take this up to 15 pounds if we wanted to. Okay. Is this graph discrete or continuous? Okay. So basically, discrete or continuous. Again, we did draw a line through here, but another thing you have to think about is it possible to buy 2.5 pounds? Can we get every fraction and decimal in between here? And yeah, you can buy 2.5 pounds of candy or 3 3/4 pound of candy. So since all the fractions and decimals are included, we know that's continuous. And you can explain that just like by what I said. Okay, you say something like it's possible to buy, let's see, fractions of pounds of candy. Okay, something to that effect. Like when you go to the grocery store and buy fruit and it says it's $3 per pound, it doesn't mean you have to buy exactly 1 pound for $3. If the fruit is a little more expensive, then it's okay. You just adjust the price. What's the slope change of rate of change of the slope for the equation? Okay, so we kind of already know that, but we can go back up here and check that we went up by 5 and up by 1, so that's a slope of 5 over 1, right? And the 5 is the dollars, right? That's the cost. The 1 is the pounds. And that's exactly what they told us in the original question. $5 per pound. That's what this means. $5 for every 1 pound. So they gave us a slope from the very beginning. $5 per pound. Okay. So I'm going to say the slope equals 5. And then the next question is where they want you to say, what does that mean? And again, that means $5 per pound. For every 1 pound, it costs $5. And let's see here. So we know our slope, right? So if we're going to write an equation, we know this is the format. We know the slope is 5, so we have y equals 5x. What's the y-intercept? Where do we begin at? You can look here, or you can look here and recall that we started at 0, right? 0 pounds costs no money. So we just started at 0, which means our y-intercept is 0. Which means we don't really need to write that. Our equation is just y equals 5x. Okay, let's do one more, very similar, just for yogurt. Okay, make a table of values and graph. And again, it tells us, before I even read the question, I'm going to set up my table. So x represents toppings, so I'm going to say this is x. This stands for toppings. And y stands for cost. I'll go to my graph and put those in as well. So these are the toppings. And this is the cost. Okay. So let's see, 50 cents. Let's see here. Now, sprinkles on top, a cup of frozen yogurt costs $4, and each topping is 50 cents. Okay. So if I don't get any toppings at all, right, 0 toppings, it still costs $4 for the frozen yogurt. Or X is just toppings. So no toppings, but it costs $4. Okay. But if I get a 1 topping, that's going to be 50 cents more. So now the total cost would be $4 for the frozen yogurt and 50 cents for the 1 topping. So that's 50 cents more expensive. 2 toppings will go up by another 50 cents. Well, now 450 plus another 50 cents would be $5, and so on. So you can see the pattern there. So I'm going up by, let's see here, 50-cent increments. It seems like most of these are 50 cents. So I'm going to count by 50 cents probably on the y-axis, and these are going up by 1, so I'm probably going to count by 1 on the x-axis. So I'm going to count 1, 2, 3 toppings, 4 toppings, and so on. I don't know if anybody's going to get 9 toppings or 10 toppings. Okay. And I'm going to count by 50 cents on my y-axis. Now, I have to start at 0. I can't start at 4 because that's the first number on my table. I have to start at 0. So this is going to be 50 cents, right? And this is going to be $1. And we have 150, right? $2 and $3, $4. I'm skipping 1 for the 250 and the 350. And then we get to, okay, this is $4.50, this is $5. So I can't just start on the $4. I have to put this in here as well. Okay, $5.50, and now we can plot. Okay, no toppings cost $4 right there. And then after each topping from here, that's when it went up 50 cents. Just like that. So a few things, we have to put this in here. That's a must. Okay, discrete or continuous. All right, so ask yourself, last time we could get fractions of pounds of candy. It's possible to buy 3.5 pounds or 3 3/4 pounds, but is it possible to get 2.5 toppings or 4 3/4 toppings? So not really. So we should say that this is discrete. Okay, that's discrete because we can't buy fractions of toppings. Okay, can't buy fractions of toppings. You gotta buy 1 or 2 or 3, nothing in between that. What's the slope? Okay, so be careful here. We can get it from the graph. We can go up 50 cents over 1. Okay, so that's one way of doing it. So up 50 cents over 1. So that's just 0.5. Okay. Okay, 0.5. That's the same as 1/2 as well. But since we're dealing with money, 0.5 is perfectly fine. 50 cents is 0.5. What does a slope mean? Okay, so that means 50 cents, right, or $0.5 is the cost per topping. So we have our slope, which is 0.5, so y equals 0.5, and our y-intercept. If you want to go back, remember we started at 4 because that was the cost of the frozen yogurt. We also have that here, started at $4. So here our cost, at the very minimum, is going to be $4 with no toppings. Start at $4. And again, if you wanted to make the 0.5 1/2, that's fine as well. Okay, so that is your review for your final. So study this several times. Make sure you can do each question by yourself, begin to end without stopping, and you will do great on the final. Good luck.